forgot to record. Yeah, that's good. Actually, I seriously forgot about it. But yeah, again, I would say I'll just repeat it. So welcome. So we are in week 5. That's true. And um,
No, recording really helps, Professor. I mean, to refer back, right?
yeah, yeah, definitely. I paused it because I logged in a little bit early and I forgot to unpause it. But that's good. So as I was saying earlier, before I started the recording, we're gonna do it in parts. First part is I'm just gonna go over some logistics, including the timeline. As you said, it's week 5, and the meat of the lecture will be about Docker and containerization. And hopefully today we'll deploy an ML model through Docker. Okay, on so we'll be using AWS this time. So in particular, hopefully towards the end of the session, we'll use a managed solution to deploy a container. Okay, so and we'll actually see a hosted solution a little bit before that, which is literally us playing with Docker by ourselves without any cloud technologies in between. So anyway, so that's the larger context. So some logistics, and then we'll look at Docker pretty much through the session. Um, but let me get into the logistics first. So first, there are a few points. Um, I just wanted to casually check if somebody attended that MLOps webinar by Databricks. If you did, then you can just message on chat. If not, it's fine. I assume many of these webinars by vendors, they would probably have a recording, and you can look back at the recording. Okay. So this was the Databricks webinar. Let me just, I think it happened 2 or 3 days ago. Um, Next, I wanted to quickly talk about, I think last time there were a couple of questions. I wanted to clear them first. So let me share my screen. So, so this is just the same. I mean, I'm just looking at the notebooks directly, and because I'm not, it's just read only currently. Okay. So I will connect to the remote machine as I've been doing before in the previous sessions a little bit, in a little bit. So I wanted to quickly cover one. Okay, this doesn't update. Let's actually, or maybe I did not commit it. Good. Okay, 1 second. Let me just do a minor thing. Yeah, just a few minutes ago, I was just yeah. So what I wanted to quickly talk about is file transfer. Right. Last time I was showing you a slightly different command which is related to SSH called SCP, and I said, hey, you can transfer files from local machine to any machine. Like local machine just means your Mac OS or Windows or whatever machine, as long as you have access to that terminal and wherever you ran SSH, right? So if you can access another command called SCP, typically it's bundled together, then you can transfer files. But if you want a GUI-based solution, there are many. By the way, for every task that we talk about, we have talked about in the previous 4 sessions, as well as what we'll see in the next few sessions, including today. All those things can be accomplished in many parallel ways. We're just using one path among these multiple choices, and that's because of time constraints mostly. So one of the second ways which I did not, which I briefly mentioned, and somebody asked, can you give us a reference, is if you're on Mac, you can use a sorry with the typos there, but you can use a piece of software called Fetch. Okay. It's available if you're through the UIC web store, and there are tutorials on, I mean, not tutorials, but some documentation on how to connect to any server. So actually, this piece of software, as well as the one below for Windows called FileZilla, they are basically GUI tools for shifting data from one machine to another, generally your local machine to another machine, and they follow what is called the File Transfer Protocol (FTP). But uh, so that's something we don't have to be concerned about at this point. But they can certainly do the same thing. They can slightly change the protocol and use your SSH key. For example, if you did a key, public key, private key pair from session 1, or if you just use the PEM file, right? When you created an Amazon EC2 instance, you can use either of them to transfer files. Okay, so you'll just get the folder, basically like a web, folder explorer on both sides, your local machine and the remote machine. You can just drag and drop and copy paste things. Okay, so these are files. So actually, if you just have text files, you can literally open a Vim on the command line and just paste something into it. Okay, so that's probably a little bit easier, but certainly you can do text files also through these options. Okay, so I strongly encourage folks who don't want to spend, who don't want to worry about this file transfer business to pick one of these tools if you're on Mac or Windows. Okay. Um, yeah. So another quick example. I think these are just some things that uh, I so we actually have this. So what I pasted here, maybe I can send it to you guys as well, is an example ML deployed model. Okay, so this is actually available through the PyTorch documentation or PyTorch tutorials link. Okay, so but let's just directly look at the app that is deployed. So it's deployed on a vendor called Heroku. Okay, and here actually they have deployed a and they're continuously running it. Okay, maybe on one of the free tiers. And so you can just upload an image and it will classify it into one of these 1,000 classes available, 1,000 classes for which the classifier was built, okay, on the ImageNet data. So let's actually try to do that, maybe just to see how you would want to have a simple ML deployed solution. um, if I recall, I do have, oh, I don't have any images to upload. So let me Google an image of a cat or something. Um, okay, so what I'll do is upload an image, and you guys can also try. So let me just go to downloads and pick. I have an image there. So let me actually browse it. So this is the image. I assume folks can see the window. You can see the image on the right side over here. So let's see if it works. I'm doing it in real time, but it should work. I've tried it before. And we actually also have an example script in our own list, a bunch of scripts to do the same thing. Okay, so it says detected image is a tabby. It's a tabby cat. So this is an example of how you would deploy a simple interface, with the GUI interface for the Flask app, which is behind the scenes. Okay, so if you actually go back to not MLOps, but um, I think it's called, actually, it's there. It's right here, MLOps code example. So let's actually click on that. So if you click on one of these, so Flask ImageNet improved is actually based on the code base that they have provided on the PyTorch website. Okay, so I think, yeah, Flask ImageNet service, for example, if you click on that, and so this is the original author, and they have, and this is actually from the and here are all the links about where and how did they deploy in Heroku. But let's come back to let's see what the model deployment code looks like. Just as a recap quickly, they're just importing a particular package called Torch Vision, which has the models, pre-trained models, like, this ImageNet model already there. So ideally you would train a model from scratch and have the model like read from disk or something like what we were doing before. But here it's already there somewhere, and they download it. Okay, so you can see when they call this step here in line 68, they're actually downloading a model. It's an ImageNet model. It's a image classification model. As I said earlier, it's a 1,000 class classification model. Okay, and then you have the usual things like Flask, import the Flask app, and some extra things which can handle this request and send back a response. Okay, and that's it. So this is bare bones, which doesn't have this GUI that we just saw, like this page. You will not get this page if you just run this Flask app. As you can see, it says, hey, if you hit predict with a file, if you can upload a file, then I can respond back with what is the class and what is the class name. Okay, so what is the class ID, and I'll respond back with the class name. But the extra step to get to that GUI was basically through this folder. So you can access these, by the way. I think folks have links to this, but I'm just pasting it now again in the chat. So if you click on ImageNet Improved, this has two extra folders. So you will have your Flask, you know, Flask Python script, which is almost the same. Okay, it's pretty much. Sorry, this, by the way, this is commented code. Okay, so this is commented text. Okay, if you use three upper quotes basically and three upper quotes at the end, anything in between is commented out. Okay. So if you look at this script, it's again the same type of imports. Everything is pretty much the same. Some extra helper functions just to get the model. It's the same thing as before. The only change you'll see is they're returning a slightly different object. Okay, they're saying, hey, return index.html. Okay, and that index.html is exactly what we saw earlier. Okay, so if you just if I press enter, this is index.html. It has nothing. This is a form. Okay, this is called a form where you can. It's a slightly different form. It's basically browse and upload an image. Instead of that, usual forms you might have seen, right, where you enter name, enter password, and create an account. That type of form. It's basically a form. So and that's what's happening here. So if you upload, if you upload something, then it'll return a result page. Okay, and the result page is exactly, it tells you the class ID and class name. Okay? Just to give you a quick context on how this simple deployed app on Heroku looks like. I would suggest folks who are trying to deploy ML models, like, it doesn't have to be this image thing, right? Whatever you're picked or you're gonna pick, you generally want to have a very simple interface like this. Okay, a simple landing page where if you haven't submitted any query, then you should have some default hey, submit some query or something like that. And then once you submit a feature vector basically, or an image in this case, then there should be a HTML response, or a result page, for example, and it can have a slightly cleaner way of saying what the prediction is. Like when we uploaded the cat image, it had the a little bit of HTML to cleanly show what the class of the input image was, right? So there's an example of a project that you can just go through as like a example project essentially. And that comes back to another logistical thing. So this was just about logistics. I just wanted to show you an example project that you could potentially perform. So right now, as Shrivani was saying, it's week 5, so we are going to talk about Docker today. So we basically have only two more sessions coming later this month. So in the next session, I have kind of dropped a couple of topics. So let me actually share the other syllabus page. I'm thinking, this is not the notes will be available, by the way. So the dropping of topics is just to so as to fit the right content in the lecture sessions. So let's go on syllabus. This is not working. So in the syllabus, what we're going to do is we're working on chapter 3, right? So we're going to try to hopefully finish most of it today. So next time, chapter 4 is talking about an extension to chapter 3. Okay, so we'll already see. So this advanced topic is not very close to machine learning deployment. So maybe we'll pick this up, or we'll directly jump to chapter 5. Okay, chapter 4 depends on Docker, and so we'll see if we can do chapter 4 or chapter 5 next session. Okay, so as I said, there are only 2 sessions remaining. So for next session, potentially 3, or Kubernetes or model pipelines. I think model pipelines is more relevant for this class, so we'll probably pick up 5. So anyway, this is a choice. And then for the last session, we're gonna talk about. I'm gonna skip PySpark because those folks who are doing big data, you will look at Spark ecosystem anyway. So it has overlap with that, so it's not really a missing topic. What you might miss is the um, uh, streaming version of deploying a machine learning model, and actually it's enabled by Spark as well. I'm not sure if folks who are doing big data are looking at streaming versions. If not, since it's an advanced topic, we'll potentially skip that and pick online experimentation as the which is basically about A/B testing. So hopefully we'll pick that in the last session. Okay. So basically, just recap, we have two lecture sessions, 19th and 26th of February, and we'll pick either Kubernetes or pipelines for the on 19th, and we'll pick online experimentation on 26th. Okay, and this is just so that we don't rush through a ton of topics and not really learn anything. We want to pick topics and spend some time on things. So that's what we'll do. And then in 3 weeks, we do have I think it's listed here um, in the project page. So if you click on the project page, um, as you can see here, we have presentations in class for all the students or student teams. So that's on the third lecture from today. Okay, so that's on March 5th. So I hope the timeline is clear, and I would, if there are any questions, you can certainly ask right now. And just to again recap, not recap, but just reiterate, the topics that we are skipping out on are potentially two. It's going to be, sorry, three. It's going to be Kubernetes potentially. You'll see that we actually do a version of Kubernetes today itself. So we may skip chapter 4, doing Kubernetes, you know, in a lot of detail. We'll potentially skip this. And we'll also skip PySpark specific topics. Okay, so in particular, what is Spark itself? And that's actually not so much related to deployment. It's certainly related to training, especially if you have large data which doesn't fit on a single machine. But because of time paucity, we'll skip PySpark, and of course its related topic called streaming. Okay, PySpark streaming, or in general streaming model deployments. So any questions about that? Yeah, so there is a question. So it's more about the project, I guess. Is there a particular report format and page number to stick to? Yes, I think certainly I would encourage folks to look at the example report components to figure out like how you want to frame your project report, project deliverable. Yeah, but in terms of page length and stuff, there is some guidelines provided. So definitely click on the project notebook, basically, to get a sense of what to do. Yeah.
Look, Professor, if we skip the some of the materials, so
Yeah.
the materials is still available for us to try by ourselves. Is that
Yes,
correct?
yes, yes, yes. That's exactly what I wanted to say earlier
Right.
when I was saying I want to reiterate something, which is that I'm gonna create that material because the material is already there. I'm gonna update it, and you can see a lot of typos also in the current material. So I'm gonna clean it up, and you pretty much will get the material at the same URL. So actually, for example, Kubernetes is already there here. Okay, but it's just that we're gonna skip over it potentially. I'm just deciding between what's more useful for us to look at.
All
I
right.
mean, the good thing about Kubernetes is we are going to look at Docker today, so it's that way it's seamless. But at the same time, looking at ML pipelines and scheduling them is a topic that might be, like scheduling, running the training every week, or dumping predictions to somewhere every Thursday. How do you do that?
Yes,
I'm just trying to figure out which topic is
yes,
useful.
that
But
is.
yeah, we'll have so Kubernetes already. For example, we have the notebooks here. Yeah,
All right. Thank you, Professor.
actually, yeah, chapter 5 also has stuff here. Um, yeah, we may skip over chapter 4 and 5, for example, or one of them, but the material will be here. Yeah. And so if somebody wants to pick a topic or project topic related to them, it's certainly you can pick it up. And if you want some assistance, me and Tengping are always there. So do contact us. Yeah. Okay. So with that, let me um, talk about again. So let me jump back into the material. So let's again use the syllabus page as a reference. So where we are is last time we were trying to deploy. So we spent significant amount of time deploying a cloud function, like and we said, hey, we just need a main py file and a requirements document which says requirements text file, which just says what are the packages that are needed, and that pretty much hopefully covers everything in terms of doing a serverless deployment, except of course you also need a trained model, for example, and you want to save it somewhere, and we said, hey, we can save it on Google Cloud Storage. Okay. And towards the end of last lecture, we were looking at, hey, we can do the same thing with other cloud vendors, and AWS Lambda and Lambda have been quite popular over the past few years on, in the general news. So AWS Lambda is exactly this, is feature compatible with basically Google Cloud Functions. And so we last time we were trying to deploy the regression model, and where we stopped was basically I had some interface like this, okay, which is, hey, test or whatever, you can give any like prediction model or whatever is the name here, and I said, hey, we just need to define. Okay, I think let me just close this execution. Yeah, we just need to have a folder, okay, which has your, of course, your function, just like Google Cloud Function. You just need a function. When somebody hits a URL, that function is triggered. Okay, so and the function gets, in particular here, the function gets what is called a yeah, the function gets an event. Okay, here it's called an event. In general, for example, if you were using Flask, it would be called request object. So it really, it just depends on the documentation. But let's but the architecture is the same. So once you have a URL, you hit the URL, very similar to Flask, you'll touch a function, and the function starts executing. Okay, uh, and uh, and what we need is, okay, if the function is going to execute, we just need if there's some things to read, right? So we need extra files. Those files can be just in the same directory, so it's really like a folder. Okay, so it's like when you're trying to deploy Lambda model, it's as if you have a small machine, small server, like a small computer, and you just need extra files which help you achieve what you want to do, for in this case model prediction. So here this is an example of a recommendation model. So what it has is basically it's a very stripped down recommendation model. So we are not even, we just want to serve predictions, right? So we don't, so what this implementation that I'm showing you here, and I'll share the code during the break. I mean, it's just a slight variation of the code that we already have in the MLOps notebook code or something that we had, right? So it's a slight variation. And what it does is, instead of having an explicit model file, like a PyTorch model file or PyTorch model file for this recommendation problem, it's actually just saving all the recommendations beforehand. So, hey, if I have 100 users on my system, uh, like the previous night, for example, I did some training. I created a model. Why not I just make the predictions, recommendation predictions, let's say 10 predictions per user or 100 predictions per user, and just dump it to file. And that's what is the file called top.n.json. Just means it's a certain type of file. And like I could have a CSV file. Instead of that, I just have a JSON file here. Okay, and if I don't want to open it, let's actually, yeah, the file just looks like this. It's just a if you read the JSON file, it's a, hey, this user ID 196, what are the top recommended movies? Okay, so I mean, it's a list. Okay, it's 1, 3 just means, hey, movie 1 should be recommended, is the top recommended. Now next movie number 3 is the top recommended, and so on. So it's just, I'm just saying that the format of top n, this file that I'm reading, which is like a dumped version of predictions from a model that I have trained before, is something like this. It's just a dictionary. Okay, for a user, give me a list of give me a list of I think um, sorry, if we open this, yeah. So sorry, I think yeah, it's just a list of predictions. I apologize when I said 1, 3 is the movie. So sorry, this 1 is the movie ID, and it should not be 3. But the second index here is just the probability of like the score that that movie achieved. You want to have high score for the most recommended movie, right? So if you can just look at it here. So movie number 408 for user 196 has the highest score. some 4.7, and then movie 64 has the next highest score 4 point something lesser, 4.76, and so on. So that's the file. And movie dictionary file is just a mapping from a movie ID to what the movie is. So movie number 1 is just Toy Story, movie number 2 is Jumanji, and so on. Okay, so so these are just minor details, but all I'm trying to say is that once you have a file, so right now, as I said, the focus is only about serving predictions, and to serve predictions you don't necessarily need to have a model. Okay, you can have the model's predictions dumped to a flat file, or the model's predictions dumped to, for example, a database, and you can just look at the database to make predictions. Okay, and these are going to be static. Every time you query the same thing, you're going to get the same answer, because the predictions are already written to disk or some location like this. Now, how did I get to this point, right? So I think last time we were not talking about this. We were talking about a linear regression model. So, and towards the end, if you have watched the recording, for example, I said, hey, we can do two things to get to, if you need to have extra files. If it was just a py file, we can just copy paste our function, right? I mean, we did this, I think, for GCP, the Google Cloud function. So here, what I've done behind the scenes is upload instead of directly uploading a zip file, I uploaded a file to Amazon S3. Okay, so I just want to show you how I did that, and maybe I can just delete it and do it again. So let's go to Amazon S3. So here you'll see a ton of buckets. So let's not worry about this. So let me actually, so how did I get here? So go to services, under storage heading, pick S3. Okay. So what is S3? It's a file system. It's a place where you can have persistent files and other objects. Okay. So for example, image files, training data, predictions, or whatever it is. Okay. So here, what we are doing with S3 is to create a zip file, and the zip file should have these three items: a py file and an extra, basically JSON files, these data files, so that I can use S3 to set up my Lambda function. Okay, so I've actually done that. So let's create a bucket. So create a bucket is like creating a folder. It's not exactly the same, but informally you can just think of it as a folder. So um, let's call it sorry, I gave a really long name just so that I remember. Okay, and there are a lot of choices that you need to make. Generally, by default, AWS tries to keep the defaults as tight as possible, and that's because might have seen in a lot of news articles about firms data being leaked, and generally it's because of bad configuration, so that people can easily extract information. So anyway, so right now, anyway, you can see everything is blocked in terms of public access. So versioning, and there are some extra details. We will not worry about all of them. So we'll not worry about any of them. So we'll just pick with the default choices. Encryption, no. Versioning, no. They have some obvious meanings. Versioning means you keep a version every time you slightly change a file. Encryption, you want to keep the file encrypted whenever it's on S3, whenever you dump it on S3, things like that. So anyway, let's go ahead and create a bucket. We will not even look at advanced settings. Okay, so we made the recommendation model bucket. Okay, so you can see it's like a fourth entry from the top, and then we click on it. You will see that it says, hey, there are no objects here. So these objects are what would be like a zip file, okay, or it could be an image file. So we can just directly, using the GUI, upload the folder. So also upload the zip file. And just to recap back, as I said, this is not the only way to create an S3 bucket or dump and delete files from the S3 bucket. Okay, there is a command line version, and that was there in the notes, but in chapter 2, but we kind of pretty much skipped over that. So here we're just doing the GUI version because it's easier, and although you may want to automate it by doing it in a programmatic way. When I said programmatic way, that way you can actually hand access an S3 bucket, list its contents, dump a file into S3 bucket using Python, for example. And that's really is a very convenient thing, right? For example, every time you update a model file, you can just there may be an extra call, extra statement saying AWS dot upload to this S3 bucket this new model file, right? So that makes it very much more convenient than to do it in a manual way. So let me upload that. So I clicked upload, and it just says, hey, what is the file you want to upload? Let me just add files here. And the recommend.zip is basically the same as what you saw here. So it's just these three files. Okay, I just already have a zip version. So these three files, and I'm going to share it after this, during the break or after this class. So we just did that. So it says, hey, okay, it's just 100 KB. We have uploaded it. And now it says destination, oh, we have not enabled versioning or whatever. So it says, so anyway, destination is this. And then click upload. So now we have uploaded the file. It says that you have succeeded. And then what we can do is click on the file name. Okay. So we clicked on the file name. This is the file that we created, right? So what we can do then is come down and we can get this object URL. Okay, so there's a lot of details about, hey, where is this file located? When was it modified? What is its size? What is its type and all that? So let's, if you look at the object overview towards the last one, you get the URL, right? So this URL is what we would need to, so what we've done so far is get our files, the py file and the data file. Using this URL, we can create a Lambda function, and the Lambda function can just take this URL and copy the files copy the files from the zip. It'll unzip it automatically. Sorry, let me close this. It'll unzip it automatically, unzip it here like this, and then you can just click deploy, and it will get deployed. Okay, so let me uh, go back to dashboard, and you'll see that I just had that test deployment, right? So I can probably delete it. Actually, that's not where I would be deleting it. So create function. Let's call it recommend as the function name. And again, it's very similar to GCP. Sorry, the Google Cloud Function functionality. Let's pick Python 3.8, and you can see that there's some restricted number of choices that you can have for runtime. And this is something that we can overcome by using, for example, Docker. Okay, so and we'll see that in a couple of minutes. And Python 3.8, and then we can just create the function. Do we need to change anything else? No, I think, yeah, create a function. I think last time, if I recall, we did a hello world example, which was literally going through, um, um, yeah, so we created a hello world example where the extra thing that we did was add a trigger and an API gateway so that, there's an explicit URL that people can access, and that will trigger the function. So we'll do that in a minute. But so we have created this. It's empty. It has a default py file, but we don't care about that. What we'll do is go to actions at the top right here, right below the test part, or so right below where the function code is there, and we'll say upload a file from Amazon S3. So here is where it says, hey, just give us the link to your code plus whatever extra thing you need. And we can just paste that here. So it has some long string. By the way, this is not publicly accessible. It's only accessible because you're using a Lambda function. It can read from S3. So let's save it. Yeah. So we just uploaded it, and you can see the three files, right? So the three files just appear here, and we can open one of them. You can see that there's actually a wrongly written Python file. There is actually no indenting. So you can see a definition of a function, and then there should be at least a couple of spaces. So let's actually indent it properly. So let's tab it. Okay, I think, yeah, four spaces is the default, it looks like. So okay, so That's good. Now we have this function. Now we can just say deploy. Okay. It says your changes have been deployed. Now what we can do is, even before exposing this model, which is just it doesn't sorry model, so exposing this prediction service, which really doesn't have a model behind it, it just has dumped predictions for every user. We can actually test it, right? So we can say, hey, let's create a test and see whether it actually works. And this is very, by the way, this is just a last minute check. We generally want to have extended testing of anything we deploy, any service. But here we're just seeing a very simple, informal way to test the Lambda function. You can, I think we will not spend too much time on testing in this session and this course, but it's a very big component of any deployed production focused service, right? So what we'll just say is, we're creating a test event. We can just say what the event is. So this is, uh, some UID. Okay, I'm just going to give some UID, and if you recall from the first chapter, the whole recommendation problems code base, the prediction model, the whatever model we picked, in particular PyTorch model, the way the Flask app, for example, was written was, you just need to pass a user ID with some user ID number, and based on that number, it will return back a bunch of recommended movies. Okay, so we've been picking 196. Instead of that, let's pick 200. And these extra keys are not relevant, so let's drop them and then create. Okay, and so now if we test it, you can see, so this is, you can see the response code here. It says, hey, status 200, headers and whatever. You can see body. We were able to successfully fetch the predictions, and in particular, the response is it's just a list of strings. Okay, instead of list of strings, you could do it in a slightly better way. You can pass back a JSON, whatnot. Okay, so what this function do is very simple. It just looked up in top end predictions for this user ID. What were the predictions? It just responded back. Okay, in that sense, it's not really a full-fledged ML deployment, but this is what you can do. And why did we do it this way? Is that Lambda has space, it has resource constraints. Okay, you cannot have too many files in this folder. Okay, not too many big files. For example, if your model is like a 1 gigabyte file, for example, that's very common in deep learning situations, you may not be able to deploy the deep learning model using AWS Lambda. Okay, so there are some restrictions. That's why I did it this way. You can also see that I have really no imports in this Lambda function. And that's because let's say you have a model, and let's say you're deploying a scikit-learn model, then you would have a dependency, scikit-learn, right? So the runtime environment that's provided by AWS Lambda doesn't actually have those packages. There's no way to install those packages, which was the case for Google Cloud Function. In Google Cloud Function, we had a requirements.txt where we could add, hey, install Flask or install scikit-learn, for example, and it would install it. On this side, we don't have access to installation like that. So what the workaround to that is that you generally need to install it within the directory. Okay? And in Python, it turns out you can install packages within your project directory, okay, locally. So remember, we were doing pip install or conda install xyz, whatever the package. You can actually do that installation within the folder, so that within this, like for example, in this recommended folder or any of the folders, and that way the package is going to be available when the Lambda function runs. Okay, not just the package, but all the functions related to it. Okay. Any questions about this? So what I've not shown is we can add a trigger, and then everybody else can maybe also use it. Let's see. Let's do that quickly. We have seen this triggering before. It's just a block which connects, which gives us an external URL which can trigger our predict function, basically, our recommend function. So let's just do an HTTP API, and security. Again, it's a bad choice to do it openly, and we don't have bandwidth to talk about security aspects of productionization. So in that sense, we are really doing a very quick journey through the world of ML deployment, and it certainly would not be just half semester, experience. So anyway, so that's my comment on that. So this should not be open in production, and that's it. So let's add it. Okay, so that is added. So you can see there's a block here and there's a recommend block there. And if you click on API gateway, it'll show what the, so okay, it shows the object, and you can click on details. And the endpoint is this. Okay, so I can copy this string, or that URL, go to, if I click on that URL, currently it's open to the world. In fact, like I can share it with you guys as well. So right now, if you don't give any input, then of course, it says, there's nothing to predict, success is false. But how do you pass a input slash question mark? Okay, if you want to do it just using the browser, question mark, and then UID equal to, let's say, 20. User ID is equal to 20. So, well, user ID 20 is probably not around, in the sense that the code that we wrote there is not really robust. So that's another thing so the thing that you should control is the robustness of your code. Okay, I know user 20 is probably not there. So let's do 200. Oh, what happened? Oh, okay. That's actually, I just want to quickly look at the logs. Hmm. Where does it say logs? State machine. Oh, okay. I think there was some misconfiguration. So let's see, what does the function require? Um, oh, okay. I think it needs a JSON payload and not a payload like this. Oh, okay. So actually, what you need to do is add a JSON payload. So maybe I'll show that right after the break, because it may require me using Postman, or there's an extra stuff that you need to do with, uh, for example, if you want to use curl. Okay, and so we saw this, by the way, just as a recap, we saw how to make a request using Python itself, using the request package, using curl, which is a command line utility. We also saw how to at least we saw the interface for Postman to do a simple get request and so on. So we have to do a get request, but it's not a request, where the payload is like this. The payload should be a JSON uh, a JSON object, and we saw that because we in testing, for example, we added a JSON. For example, in the definition of the sum UID, you saw what was the input, right? So you can see that the input is supposed to be a JSON input, right? Although it doesn't show the input here, but the input is supposed to be that squiggly, curly braces, UID is equal to something, right? So that we can't do directly using the browser. At least I don't know how to do it right now. Okay. Success is false is true when you click on the URI. Thanks, Shivani. That's because we did not pass a user ID. And I was just commenting just now that you can't just pass the input argument like this. Okay, so you need to give a JSON input. So which I don't want to do it in real time. So that's why I'll show you how to pass an input maybe right after the break.
Or
So anyway,
maybe
so
you can
just
send a demo, professor, or you can upload the JSON input there so that we can try it later.
yeah. I mean, actually, we just need to open Postman and do it, but I didn't want to do it in like real time.
That's
Yeah.
fine.
So
Later.
I mean, the link will be on. Certainly, I'm not going to remove this function. So it's just that if somebody wants to figure it out, you can do it. But I'll just show it right after the break. Okay, how to pass a JSON as an input. But it's the same URL. We'll keep the same URL.
I had another question I asked you. Maybe you pasted the URL there. Why did you not choose a REST API?
We can choose any. I mean, so there's slight differences between them. So REST has this particular structure of how to do it. So HTTP is just it's okay. It's HTTPS here, but it doesn't really matter for us at our level. But it's a good question. Actually, when you deploy an ML service, then you would generally want to adhere to the REST type of architecture, where um, the URL paths basically should conform to how you want the client or whatever the intended service user to use your service. Okay. let's not get into that detail about REST API versus HTTP API right now. But yeah, I would say we are doing just a minimum working example here, but it's a great question. We can pick either. In fact, probably the latter, as you said, is probably better choice. Yeah. Um, let's stop this for now.
Professor,
Yeah.
I do have a question regarding the Lambda. So,
Mhm.
so as you saw us, like you input a JSON file with all of the predictions, you already run it and then train
Yes.
it and put it in. So how can we update it when we train a new model?
Exactly. So that's exactly the reason why I said we dumped something here, right? So remember we were
Right,
dumping
right,
we dumped recommend.zip, right?
right, right,
So every night, for example, if you redump this,
right,
so actually that would not help. I
okay,
apologize. What you need to do is, I mean, here I'm reading it locally, as you can see,
right,
right? Instead of reading it locally, uh, you can actually directly access S3 objects from Python. Okay,
okay,
and that's what I was saying. So, for example, we use the GUI to upload something, download something, or look at something. We can actually do it using Python. And so, for example, within this script, instead of like with open like a local file here, you
mm-hmm.
can actually access the S3 bucket. And hopefully, in S3 bucket, you don't have this. You only have this, let's say, new top end JSON file that you can read.
Okay, all right. So,
So it's very similar to what we did in GCP. In GCP, we had on the Google Cloud.
mm-hmm.
Sorry, what's it called? Let me just tell you exactly what the name is. Um, Google Cloud Storage, GCS. Sorry, there's so many acronyms. GCS. Storage. That's it. So in storage, we had dumped a model. So I mean, it's same idea of bucket, and within that there was a pickle file that we had dumped. Instead of pickle file, just think of it as like, hey, we dump predictions, for example. And if you go back to our, I don't know if I have the functions. Maybe I don't have the cloud functions. Um, if I don't have it, apologize. But basically, okay, I don't have it. So basically, in that cloud function, last time I think you can go back to the recording
Okay,
where we had explicitly called. We are directly accessing the bucket using a gcloud package. Okay,
okay.
and we'll probably see a version of it later today. So I hope it'll make it clear. Yeah,
All right. Thank you, Professor.
yeah. Um, Yeah, that's a great question. How do you change it? You just need to change this file, and that's not easy to do. The way to do it is to directly access S3 every time. For example, every time you're running this function call. Okay, and so every time you read S3, maybe you update the version, updated predictions there. It'll read the new predictions directly. So you should not. So because the way we deploy Lambda function is GUI or manually, is manual. So um, there's actually probably even automated ways to do it in the documentation. But since this part is manual, we can only overwrite a function that this guy will read and predict. Okay.
Okay.
Um, Great questions. Yeah. So next, what I want to spend on, and this is something that we did even last time towards the end, is talk about Docker. Okay. So I'll just recap what we briefly discussed about Docker, and in fact, we'll spend a few minutes today talking about Docker. So we have pretty much, we looked at two parts: serverless technologies, right? Google Cloud Functions and then AWS Lambda functions. Uh, they have some limitations, and that's why we are going to talk about Docker, and we'll probably a couple of times contrast with serverless technologies. So for the rest of the session, we'll revisit what is meant by containers, and in particular we'll look at Docker is not the only container implementation, not the only way to set up a container or run a container or whatever. There are other options. For example, um, let me just give you a link to a competitor or an alternative technology. It's called uh, uh, Podman. It's a different um, manage pods or containers and container images. So it's a slightly different implementation. Okay, but we'll not look at that. We'll look at Docker today. So and then what we'll do for the first half is actually go over, and this probably slight deviation from the notes. We're going to try to use the Docker's tutorial in real time, and they actually have provided a nice virtual machine with easy access, and we'll go that route instead of our nodes to work with Docker initially, and then we'll get back to deploying models on Docker. So first we'll try to understand how to use Docker with some simple, we'll understand different components of Docker and maybe deploy something simple first, okay, before we talk about machine learning model deployments. So key things, as I said, difference between containers and virtual machines, how to create a Docker image which leads to a container using something called a Docker file. It's just like a Python file, or it's just like a text file, but it has a few sentences which say, hey, set up port like this, or set up copy files like this, or we'll talk about it. So that's basically the new thing. And then once you have this thing called an image, you need to put it somewhere, okay? And it's called a registry, and we'll see how to put that into a registry where that image can be used to deploy a container elsewhere, okay? So there's this intermediate point. You create an image somewhere, maybe on your local machine, maybe on EC2 somewhere. You have the image, you need to dump it somewhere, just like I wrote this notebooks on my local machine, this IPython notebooks, but I dump it on GitHub for somebody else to access it, right? So similarly, a registry is just like a GitHub type of a location where you dump an image, somebody else can read it and deploy a container out of it, okay? So we'll talk about what an image is anyway pretty soon. So these are pretty much the goals of this chapter, okay? So let's actually talk about Docker in detail. So yeah, so so Docker, as I was saying, is basically a variant of this container solution. And I just gave you a link for another variant called Podman to manage containers and all that. So what are containers, right? Just to recap, they are basically tools to produce reproducible environments. Okay, so basically an isolated environment. And when I say environment, it's surroundings, things that your app or that your script can see. Okay, so our script is basically a Python script in most of this course, and the script is going to say make a prediction or train a model. Okay, so the script can see a few things, right? Whenever if you run a script on your local machine, it will say, hey, your local machine has a memory of 16 gigs. Your local machine actually also may have a GPU, or your local machine has 8 cores or 6 cores. Those are information that the script can see, and therefore make use of those resources. Okay, so containers are all about what can a script see, and hopefully the script sees the same thing, irrespective of what the real machine is. Maybe it's a Mac machine, maybe it's an EC2 instance, or maybe it's my machine. If you want to make a script, your Python script to see the same things, then you can somehow create an object. And that object is called a container. Okay, so and it has everything that your program or script needs, independent of is it Mac OS or is it Windows or is it Linux? Okay, um, um, and there are a few. I think here I'm just saying that it's lighter resources than VM, and we'll actually see a figure in the next section to further talk about this. So containers, I won't spend too much time here because we did discuss this last time. The summary of containers is that basically you get consistency, okay, which is basically that let's say I developed some app and I know exactly what the requirements are, and if I can put that app into a container, or basically a container related thing like an image, then my teammate can get the same environment. When he runs my app, the app will see the same environment even though his machine may be different from my machine. Okay, or I can deploy the same app on AWS and GCP. Even if the underlying resources are different, the app will not know about it. Okay, it'll have everything that it needs to run successfully. Okay, and that's portability. Right, you can run once you have this object which encapsulates your script, you can run it anywhere. Okay, and it's like, I think for folks who did Java before, it's like you compile Java to a bytecode, and there's a JVM or Java Virtual Machine, and that lets you only compile to JVM, and because there's JVM available for multiple different architectures, you don't care about where your Java program runs, right? So it only needs a Java virtual machine to run. And it's also lightweight, okay, and we'll talk about lightweight in a minute in a little bit more detail. And lightweight is just a related thing. It's lightweight compared to a complete virtual machine. Okay, so in the sense a complete computer. So it's not a computer, this container idea, and we'll talk about it. So that's containers, and we'll look at Docker. And when we look at Docker, we're gonna operate in a sense the way we operated with Flask. Okay, it's gonna be a managed version. Sorry, it's gonna be a hosted version where, hey, we'll have this some command line command line statements to make or commands to run. And we'll be able to start a container, and it will start serving requests. For example, if the container contains let's say Flask script or a Flask program, then we'll be able to we'll be able to deploy the machine, so deploy the model, and take make predictions. But there is a managed version of this, clearly. So every time you have a direct way to do it, there's always managed versions to do it. And managed versions, there are many. One of them is called Elastic Container Service, and that's what we'll try to see towards the end of today's session. So it's a proprietary solution by AWS, so it's actually not open source. But it's basically similar. So if you come back to once you make containers managed, then what are we getting? So how is it different from, let's say, a Lambda? And so in a sense, it's very similar to Lambda in the sense that it makes you agnostic. It lets you be agnostic to a lot of DevOps details. And when I say DevOps details, everything about, hey, what is SSH? Why do you even need SSH access to the machine which is running your app? You don't need it. And so those are things that are directly managed. Okay, server config, how many CPUs, how many, what software is it running, is it updated, and all that. It's kind of taken care of, or at least it's made it so easy that you can, using a GUI, choose things. Okay. So in particular, ECS, as if we see it later the session, they're going to lift some restrictions on Lambda functions. In particular, as you saw, I think briefly, when I was picking an environment, I only got Python 3.8. For example, let's say your app needs Python 3.9, right? It has some specific Python 3.9 features that it wants to use. Then you can't use Lambda, right? So there are some restrictions. And similarly, there's some limit on how much memory you can use. For example, in Lambda, as I said, if you have a deep learning model and if it's a 1 gig bunch of weights and there's millions of weights and you want to load them into memory to make a prediction, you are limited by 256 megabytes of memory. Okay, so that's quite limiting. So but with ECS, you since we are setting up we are just ensuring that a container runs. So we get to specify a lot of things about what the container can access, right? For example, hey, if you need Python 3.9, I'll create the container and encapsulate it around my app or my script such that it can actually use Python 3.9 and not be limited by, for example, whatever we saw with Lambda. Okay. Yeah, so basically we'll look at some Docker experimentation, and then we'll try to run Docker on. So actually these two steps we'll do together. We'll actually we'll see this pretty soon. Next, after that we'll look at Elastic Container Service by AWS, and that's not the only service. As I mentioned at the beginning of this lecture, Kubernetes and managed versions of Kubernetes, Elastic, I guess EKS, Elastic Kubernetes Service, is a way to also manage containers. Okay, and Kubernetes is an open source technology, unlike Elastic Container Service. But they're all about managing containers. But we'll see if we pick up Kubernetes next time. Any questions about the very high level intro to containers? We're going to look at Docker in a little bit more detail. So maybe many of your questions will be answered when we look at that. Okay, so what I'll do is just quickly go over how Docker what are the different components in this technology called Docker, and that's all we need to know. We don't need to know many of the low-level details of Docker, but we just need to know what are the moving parts and where do we come in as, hey, we want to deploy an ML app, or we want to deploy any other service. Like, we had weather prediction example, or we had that random food image example, right? So we have Flask apps or Flask scripts which we can deploy. The question is, how do we put it into a container and then deploy it? Okay, that's the point of view that we're taking when we're looking at all this. So um, so as the text says here, so Docker is a platform. It's useful for developing, shipping, and running applications, and primarily via containers. Okay, and it has all these benefits, and we have already spoken about many of these benefits, so I will not bore you with that. So let's look at what are the moving components, what are the components in Docker. Okay, so as I said, a loosely isolated environment is what a container is. It's an isolated environment, isolated from which host operating system, whether it's Windows or Linux or Mac OS or whatever it is. Okay, it's the program is doesn't need to know whether it's the Mac OS or Windows. The container provides the isolation, and such a thing can be created using Docker. Okay, such a isolated environment can be created using Docker, and we can have multiple such isolated environments on the same machine. Okay, so for example, um, you can have 10 different apps or 10 different ML models on the same machine, and one app, for example, may depend on Python 2.7, and one app may depend on Python 3.9, and another app may depend on maybe some databases, for example, like a SQL Server. You can have all those containers on the same machine. Okay, so, and why can we do that? Because each container is essentially a program. Just like if you folks who are on Windows, when you open Task Manager, you'll see a bunch of exe files or whatever processes running. So a container is going to be a process. Okay, and that's why they are light. Containers are light because they run directly with the host machine's what is called a kernel. Okay, or you can say it directly runs as a program on the host machine, okay, rather than as a virtual machine. So folks who have tried out virtual machines, for example, installing VirtualBox or let's say VMware Fusion or something like that, virtual machines are much more complex objects, complex programs within which you can run an entire other operating system. For example, on Windows, you can install VirtualBox and run Ubuntu on it, right? So they're much more, relatively speaking, heavyweight. Okay, and when we say kernel, we're always saying is kernel is that object which basically interacts with applications. So any of the program, let's say your browser, your the Zoom app, for example, all of them are interacting with the kernel and accessing resources. For example, Zoom needs 10% of your CPU. That's it's accessing through the kernel. Okay, and similarly, if Zoom needs 1 gig of memory, it's accessing that memory through it's getting allocated that memory through um, kernel. Okay, and also accessing devices like keyboards and cameras and all that. Yeah. So that's actually, that was just to give you a sense of, hey, containers are lightweight because they directly somehow talk to this kernel, and we'll actually revisit that point once again in a minute. But let's talk about Docker. Okay, so Docker or Docker engine, why is it called engine here? It's slightly different from what is called Docker desktop. So if you go to Docker's website, they'll say Docker desktop or Docker engine. Docker engine is a name for, I guess, Linux-based installations of this program. Okay, so it's an app. It's just a program. Okay, so it involves a few components. So first component is a server. It's called Docker D or Docker daemon, or it's a server, and that's the guy which is running. It's a server. Sorry, it's a server program which actually does the creation of containers and whatnot. Okay, there's isolated environments. Okay, and this guy, since it has to create containers, it has to speak through a language. Okay, so somebody has to tell them through a particular language, oh, hey, create a container for me, right? Or delete a container for me, or stop a container for me, right? So that's through what is called an API, and we have seen API, earlier, like the gateway API for Lambda. So that's the way, as some language with which you will talk to the server. Okay, and to make it even better, there is actually a command line utility called Docker. Okay, this is the command line utility. It's a program. When you install Docker, this utility uses that language to talk to the server. The server is the guy who does the provisioning of containers or whatever, these isolated environments, and Docker is a way to say, hey, create a container for me, or stop a container for me, or and things like that. Okay, so you can look at this diagram. So Docker daemon, or the server, is the guy which can talk through REST API, and that's, I think Shivani just asked, why HTTP API or REST API, some API, okay, some way, formalized way to talk to others. Through REST API, it can talk to a client, okay, and that client is called Docker. It's just literally that name, just like Vim file name is Vim is the name of the editing program, right? So we have Docker, and through this interaction, the server manages several things. Okay, it manages creating, manages containers. As I said, it could be multiple containers. It can manage what is called an image, and we'll talk about what is an image pretty soon. It can also manage several things. If a program has to run, it also needs to have access to maybe the network. Okay, in the sense that it needs to access the internet. So there should be a path for it to be accessible from the internet, right? So there's some network details that it also manages. It also manages, storage, right? If I'm running my app in a container, uh, there should be a way for me to also do dump information to disk or some other place, or read information from disk, as in like a hard disk or some other place. Okay, so that data stuff is also managed by this guy, the server. So let's look at this picture to make it even more concrete. So there's a client. So on the left side is a client. Okay, it's issuing these commands, this language, right? So hey, build me something, or run something. Okay, pull, we'll see later. And there's this Docker. The center blue box is showing there's a Docker daemon. Okay, daemon is just the server app. Okay, and that's the guy which is saying, hey, let me look at what are called images, and from images it's going to create containers. Okay, and we're going to talk about images, as I was saying, in a minute, so bear with me for a second. So given images, it will have access to images, and from there it will create containers, or it will delete containers, whatever is the command being sent by the client. And where do images come from? So typically images come from what is called a registry. It's very similar to GitHub model, right? So think of registries like GitHub. If you want to get code, you generally clone from, you pull from GitHub, like git pull or whatever, git clone. So something like that, So a registry is like that. Okay. And so from registry, so what does this registry have? It has images from which you can create containers. So as I said, containers are isolated environments. So these images are things like, hey, give me an Ubuntu environment, which is exactly 20.04, which has exactly Python 3.9. Okay, so that could be one image that's available, somewhere, for example, on Docker Hub, or I'll talk about what is the equivalent of GitHub here, but from there you can pull that image and you can run it. Okay, and once you run it, you can, typically you don't directly run something you pull directly. So if you want to add your files, right? So somewhere you need to add your files, and that addition of files will again do that by issuing an appropriate bunch of client commands to create a local image. Okay, so we pull a base image, something from outside. Let's say it has Ubuntu and it has Python. Now we want to put our Python file, like a Flask app, into that image and create a local image. From there, if I say, hey, Docker, run this image, and that'll create an isolated environment, it'll run my app. Okay, that's the steps that are going on. Yeah, so I think this is pretty much what I said in text. So I will, what I'll do is just talk about sorry, let's quickly talk about containers versus VMs one last time, and then we'll switch over to some hands-on stuff. So you can see this figure. So the left side is showing how containers run, and the right side is showing how VMs run. Okay, so let's look at the right side first. So if you've installed VirtualBox, then then in VirtualBox, for example, you can create a new virtual machine, and the machine will have what is called a guest OS. Okay, guest OS is, for example, in Ubuntu, or some other, like Windows itself, like an older version, for example, or it could be even Mac or Mac OS. So you'll create a virtual machine, and the infrastructure at the bottom is actually the resources that are there on your actually physical machine. Like, for example, you have 16 gigs of RAM, and you have, let's say, 1 TB of hard disk or whatever spaces. That's infrastructure. There's a program called Hypervisor that will deal with how to virtualize these resources or provide enough resources to the guest operating systems. The guest operating system, from its perspective, it's as if it's on a physical machine, but it's not, right? So this guest operating system is actually just running within a program called VirtualBox. So from the guest operating system perspective, it just gets a feeling as if it has all these devices, or sorry, all these resources. And then it'll have, since it's an operating system, it'll have its whole set of bunch of files. If it has Windows, you can imagine it has program files, app data, whatever, the many different folders, right? System files and all that. So it'll have all of that, and then you can run an app on top of it. Okay, so for example, you can run a browser inside a VM, right? In a Windows VM. Okay, so those are, that's what it looks like. And then if you have different VMs, then they will have their own guest operating systems, and nothing is shared between these guest operating systems. Okay, they're all isolated environments. On the left side, you can see that there is no guest operating system at all. So there's infrastructure, and there's a host operating system like a Windows, Linux, or Mac OS. And then there's this daemon, this Docker daemon, which is provisioning containers. Provisioning just means creating, destroying, or running things. Okay, so it's running containers. And so actually, from the perspective of the host operating system, these containers are just apps by themselves. Okay, apps just means, think of them as processes. Like, as I said, if you're on Windows, if you look at Task Manager, you'll see a bunch of processes, right, with some resource consumption. So that's all it is. So a container is just a process like that. Okay, so on Linux, it's exactly a process. Okay, so if you know a little bit about Linux, so so these different containers, although they are isolated environments, they're all directly talking to the host operating system, because they're processes, right? They're just programs. So they're directly talking to the host operating system to get resources. For example, app B, a container which is inside a container, may need let's say 1 GB of RAM. Okay, so it'll directly talk to the host OS or the kernel in the host OS to say, hey, I want 1 GB of RAM, and it'll get it maybe. Okay, if it's available. Similarly, app A will directly talk to the host OS to say, hey, I want 10% of CPU or 2 cores of CPU for the next 2 minutes, and that's how it gets the resource directly. Okay, so that's the extra guest operating system is not there, and in that sense, it's lightweight. Okay, any questions about this before we jump on to some?
See, so essentially multiple containers can have different versions of the same application, essentially, right?
Yeah. So although the container, from the host operating system perspective, there's just going to be one process, like opening a browser. Browser is going to be one process. Generally, it's not really the case. It's more complicated than that. But let's say you open Notepad. It's just one process from the perspective of the operating system, right? Notepad++ is just one, or Notepad is just going to be one process. But inside the container, you can have Python 3.9, or you can have your ML deployment app. In another container, you can have the same ML deployment app, or you can have a slightly different Python version and have an app there, for example.
See,
Yeah.
in theory, I could do the same thing in a standard Windows as well, right?
Yeah, but they will not. Okay, so this Python is not going to be the same as this Python. So it will be like a local version. Like it's like
okay.
Conda environments,
Okay, all right.
It's not. It's like Conda environments, but not the same. Yeah. Yeah. So for example, app A is, let's say, using Python 3.8. App B, if it's also using Python 3.8, they are not shared. Okay, and in fact, those Python 3.8 are not even visible to the host operating system. Okay, you don't have to install anything on the host operating system at all. You don't have to install Python at all. Okay. So in that sense, it's a container is.
So those files and libraries are held by the container. Sorry.
Yes. And that, how do we get that? Is through images. Images will have like a snapshot of those files, and when you instantiate a container, it'll read those files, and it'll only app will only be able to see those files, and so it'll know that, hey, I have Python. I don't know what's there in the host operating system, but I'll since I have Python, I'll run something like that. Yeah.
Okay, got it.
Yeah, I think it'll become more clear as we do a little bit of hands-on things. And this is where I think what I'll do is move on to a different page. It's called, so if you go to docker.com, actually folks can access this. Yeah. So if you go to docker.com, this is the company behind that technology. And you'll see on products, for example, it has Docker Desktop, Docker Hub. So Docker Hub is that thing equivalent to GitHub, where there are images which you can pull, which the local thing can pull and create a container of it. Okay. But we'll just directly don't pull, and generally you don't just pull and run a container out of it. If you're a developer or if you're an ML person, then you also want to inject your app, right? You want to serve an ML model. You pull an image, you add an extra thing, which is like your app code, and then you create a container out of it. Okay. You can explore this website maybe a little bit later, but what we're going to do is use this particular page, Play with Docker, to directly get a hands-on experience with Docker. Okay. So how do you do that? So you can see there is a yeah, let's click on Docker 101 tutorial. In fact, we'll actually go through this tutorial because it's going to have almost the same content as what we have in the notes. So let's click on that. And so it says, hey, this is a tutorial, and you can actually see there are two choices. Okay, Docker, you can actually do it locally on your machine, and it says download something onto your Windows or Windows or Mac OS generally. But I don't you don't have to do this because if you don't want extra software unrelated on your machine, what you can start with is the second option, which is called Play with Docker. Okay, so that is so you can this is the URL here, and for this you just need to create a simple account on Docker's page. Okay, so you can just create a free account. You also have paid accounts. As I said, there is this notion of a registry, so it's very similar to GitHub, right? On GitHub, for example, you can also have a paid option where you can have more repositories, more features, right, on GitHub. But you can also have a free account. So Docker has also made that available where you can have a free account. So you can create one using or get started or sign in basically. Once you create that, then let me just close this. You'll get something like this. Okay, so once you create that and you click Play with Docker, you get if you click on Play with Docker, you'll get an instance like this. I've already logged in. So since I was signed in and I clicked Play with Docker, I got to this page. Okay, so actually, let me just delete this. Yeah, so you'll get a page like this. Okay, and what I can do is so is this clear? So how do I get to this point? I don't want to lose folks at this point. From here, I'll show you how to play with Docker a little bit, or get a sense of how to work with Docker.
And this is essentially, if you were to sign up on the page, this is where you will get to, right?
No. Once you sign up, you have to go to that Docker 101. I think. Sorry, not this.
Okay, got it.
So I think
it
I
is
just
essentially navigation
already.
that you slowly.
Yeah, I think I've already logged in. So if not, I can. Yeah, I just created. So this is my account, whatever. Right. So I've already logged in, and you don't have to go here. I think you just have to go to Docker. I think it's not Docker Hub Basics. Yeah. Once you're here, you just delete the hub part. Okay. Go to Docker. Actually, let me close this also. Leave page. So once I've logged in, so although it doesn't show login here, so then go to developers getting started, or actually Play with Docker directly. Okay, click on that. Actually, let's click on 101 tutorial, and then let's click on this link here, labs which is what I shared in the chat. Okay, click on this. If you have logged in, then it should then it should already, it'll come to basically page like this. Okay, it'll say, hey, simple interactive playground to learn Docker. And what is this playground? It's actually giving us a virtual machine. So all the stuff that we've seen in the previous sessions, these guys are just providing a simple virtual machine for us so that we don't have to worry about installing Docker. Okay, that's all they're doing. So that if you click on start, okay, then you'll get an interface like this, and you can say, hey, let's add a new instance. What is this instance? It's just a virtual machine. So as you can see here, when I clicked on that, it said there's some IP address, and it says, hey, this is a sandbox environment, don't use information. And it's basically exactly the command line stuff that you have seen before, right? So ls works, and so on, right? And there's some IP address, okay, and some random string here. So you have this, okay. So the cool thing about this one compared to the AWS machine, for example, is that Docker is already installed. So if I type doc or Docker, you can see there's a command here, okay. So what we'll do is now start going through the tutorial. So for that, what we need to do is run one command. It's called Docker run, okay. And it's, as I said, so this thing here, this Docker command line utility, that's what it's called. It's gonna, when you run it, I'm gonna issue a command run, okay. So this is gonna go to the server, which is so the server app, which is running on the same thing. It'll send through the API, through an appropriate language to the server, and that server will actually create a container, for example. So let's create a container which will have a walkthrough of some basics of Docker, okay. So -t means do something in the background, okay. It's a -d means daemon mode. Port, we're going to specify a port. So sorry, I'm just going to show you an initial command, and then we'll get to 101, okay. And so how do we get to the 101 part? Let's run a simple thing, 8080, and then Docker / getting started, okay. So let's just do this. So what does this command mean? We're going to talk about in right now, okay. It ran something and it says, okay, oh yeah, it did something, right? There's some text that got printed, and now it came back to my whatever the original command, so command prompt, okay. Now, but what happened is an extra thing. You can see there's an extra 80 symbol here, okay. So let's click on that. Okay, so now it's showing a bunch of tutorial. Okay, so we can go through these tutorials. By the way, you can access the same tutorial directly without doing all this playground stuff. But I wanted to just show you that this thing is actually running through a container. This container. So what we did just now is run a container by just issuing this command. Okay. Okay, there's a question. What is that time? Oh, this timer at the top is just, hey, you only have a four hours to play around with Docker. I mean, you can recreate, you can restart, and so on. It's just for you to get used to Docker. Okay. Don't worry about the timer. Yeah. So anyway, so what we did, we created a new instance. We just ran one command. Okay, just this command. This command, what it did is actually run a Docker tutorial. Okay, so sorry, start a container, and that container actually has just the static HTML pages. Okay, and in fact, we are seeing that HTML pages from this container. So you can see it here, right? So we just started a container. Okay, so that's great. So we just had to log in, play with Docker, and just run that single command. So this is the command, by the way, in case you don't want to type it in the original thing. And now what we have is we have a few things. So this is a command. Okay, the starting point is the utility, CLI utility, and then say run something. Okay, and what is the something? -d says run the container in a detached mode in the background. So run something, this isolated environment in the background. So don't don't interrupt my command prompt. You can see the command prompt is back to me. So clear, I have the command prompt here, right? So that's what that -d means. And then -t means port forwarding. So whatever is the Docker, if I run an app, it runs at some port, right? But remember, it's an isolated environment where the app is running. It'll have its own. It's like the app is running in a computer by itself, although it's not completely a computer. We just discussed that. So local port. So the app will have its own idea. Hey, I'm running on port 80. Let's say my Flask server, right? It's just saying, hey, whatever the Docker thing is running, just forward it to the port of the host machine, okay, which is 80. It's very similar to that SSH idea, where the local port 8889, for example, should map to that port of Jupyter running, on the remote machine, which is 8888, for example. So that's just, it's port mapping. And then this guy is actually an image. Okay, this is exactly what I think George was asking earlier. So this thing is an image which will have all that information of, I want to run some files or the Python. So then Python will be there in this image and the whole file system, so that the app will only be able to say, hey, this is my environment now. Okay, so that's this image, and we just ran it. Okay, so and then there's some, we'll skip this part, but if you're on Windows, you can certainly install, and if you want to do these things not in the browser but on your own machine, then you can certainly install Docker on your local machine and follow through. Okay, if you see the recording, for example. So let's actually move forward. So what is a container, right? So we have already discussed this, but simply put, a container is simply another process, another program on your machine that has been isolated from everything else. Okay, everything else from the machine. So if our Python script is running within this process, then it will not see anything else on that machine. In that sense, it's portable, right? So so that's what it is. And you can actually look at this really cool video where they actually build a container idea from scratch. Okay, and although they use a language called Go, you don't need to know the language, but it's a really nice tutorial. It's not at the beginner level, so for folks who are more interested in how this whole thing works, there's a good video to look at. But let's move forward and actually do something more interesting. Okay, so what we'll do is in their tutorial, in Docker's tutorial, they already have an app. Okay, and we don't really care about how the app is built and all that. Okay, no details. Although in this case, the app is built using it's JavaScript app, so you can run it using Node.js. But for us, it's irrelevant. It could have been just a Python. In fact, we would love to run a Python app, and we'll do that in pretty soon. Okay, so let's actually get the app and run this app on that machine. So this is actually a machine. Okay, so as I said, this is a virtual machine where Docker is already there. We're gonna get that app, and we're gonna pull an image. We have this app files. We're gonna merge them together to create an image, and then we'll run that image to serve that app. Okay, those are the steps. So let me just do the initial steps, at least now. So let me copy link location or whatever, copy the URL, and just do wget, get the thing. So wget is just a way to download something which has a URL. Okay, but as I said, there are many ways to achieve the same thing. So we got this. So how do I know this? Because you can see that there's an app.zip, right? Then we just need to extract this folder. So extract, sorry, that zip file. So unzip app.zip. Okay, it's saying inflating. So if you look at the folder again, there's an app folder, right? So let's go to app folder, and you can see that there's a bunch of files. Let's not, we'll not be really worried about any of these files. So instead of me jumping back and forth between these tabs, let me copy this URL into another window so that I don't have to switch between. Okay, now what we'll do, okay, so we just copied, so we just got the app folder. We just got the app zip file. We unzipped it. Okay, so just say, so by the way, because it's a Node.js app, it has these, some weird folders. If it is a Flask app, it would be just, Flask app.py or whatever is the name, we've been giving, for example, previously when we deployed Flask apps. So it will just be flask.py. Now, the most important thing is that we need to create a file called Docker file. Okay, so Docker file. Okay, and that's how we are able to create an image from which can use our app data, sorry, app files, and some base image. Okay, and base image just means, hey, I want Ubuntu plus Python, let's say, or Ubuntu plus Node.js. I'll get that from Docker Hub, which is a registry. I'll use my app data. Together, I'll merge them together to get an image. Okay, so that's what I'm going to do. So Vim Docker file is just create that file. So let me insert those lines. So you can see there are 5 lines. Okay, so it's saying, and these are basically how a Docker file is specified. Okay? It's just a config file. Basically, it's saying, hey, start with a base image. It says start with something, start with some like Linux like environment which has node already. Node is that technology which lets you run JavaScript files. So start with that, and then say have a working directory called /app. Okay, which is just in that environment that I'm going to create. I'll start with this, which already has. Therefore, it has if I put a script there, it'll be able to see node anyway. Let's create a directory called /app, and then copy. I mean, go into that. Sorry, in the second line, and then copy all the current files that I have in the current directory into that directory app. Okay. Um, and then install all the required documents. This step 4 is basically saying install all the dependencies, okay, all the packages. In Node, you do it using yarn install, but if it was Python, you would just do pip install -r requirements, something like that, right? And then it's saying last step is run something by default, okay? It's saying run node app source index, okay? It's just like saying Python file name.py, okay? That's all. So these are the 5 steps. Start with the base image, create a directory called /app, put all my files in there. Step 3, install dependencies, and then start my app. Okay, so that's the Docker file. So, and then I can do shift:\wq to escape from that. So what has happened is one extra file has been created. You can see that there's a Docker file, and previously there are these previous things. Okay, and then the next step is to again ask the Docker daemon to now build an image. Okay, now this built image will have my app information and the environment related stuff like node and dependencies and all that. So the way you do it is Docker build, okay, -t is just saying, hey, give me a name for this built image. So we'll just say we'll just keep this something similar to what the tutorial is saying, getting started. And then dot. Okay, dot just means in the current directory you will find a Docker file, see that file, and create my image. Okay, so plus enter. Okay, I think I messed up with the name. So you can see some steps are happening. Let's probably once it finishes, maybe look at it. It's saying, hey, we're going to create. We're starting with some base image called node : whatever alpine or something. That's, don't worry about it. It's just a specification of the files, what the app should see. And then it got that information from Docker Hub, okay, or something like a GitHub. And then from there, it's saying, let me execute now the new steps, like create a new directory /app. From there, let me copy everything in the current directory. Dot means current directory to this current directory, which is the /app directory in the container. And then install things which are related to this app. There's going to be a ton of things potentially. And yeah, and then run. Sorry, and then the last thing that you should start whenever I create a container from this image is node the file name. Okay, so that's great. So how do we know? So it says successfully built. So what we can do is Docker images to get a sense of what images are there. So we have few images. Okay, the most important is the one that we just created, getting started. Okay, so that's the one where we put our app related script into a base image. It's called 12-alpine, but whatever, some name. And remember, the first thing that we did was to actually import an image or clone an image called docker/getting started, and we ran it, and that's where we got that this with all this information. Okay, so yeah, so let's actually go back there. Okay, so I said the image is now present. Now what we can do is actually run that image. Okay, so to run that image, we'll do exactly the same thing as what we did at the beginning of this whole thing, which is what I pasted in the chat as well. So we'll say docker run -d, but this time we'll change the port. We'll use the port 3000 colon 3000. Okay. Why 3000 is because just like in if you by default run a Flask app, it'll run at port 5000. Okay, by default. Similarly, there's Node.js apps. If you by default they'll run at 3000 port. Okay. -d again just means run it in the background, and then and the image that we want to run, create a container from, and therefore and run it is getting started. Okay. So something happened. So I got a long string. This is actually the name of the container. Okay. So this is the, I guess, the unique ID of the container. Now, how do I know the container is running? I can do docker ps. Okay. PS is just the list processes. Press enter, and you will see there are two containers running already. So the getting started one, we just we started because we wanted the tutorial. That's literally what we accessed here, and actually everybody else can also access the same thing. So let me, I don't know if you guys want to see the same thing, but that's the thing. And then there's another container that you can see, hey, it was created 19 seconds ago. It's still up, it's running, and its port is, whatever the app inside has a port that has been mapped to the host port 3000. Okay. And it also has names. Okay. This is called Sleepy Poincaré, and the other one is called Wonderful Panini. Okay. Some random names were given. Now, okay, so we deployed the app. Now you can see when I ran that, actually, we didn't focus on it, but there's another extra thing that's only because of this interface. There's another extra link that came up with, which is this 3000. So if I click on that, you'll see this is actually the app. Okay, so Control C, and folks can actually access it because it's I think it should be universally accessible. If not, you can just let me know. But this is the app. Okay, this is a JavaScript app which says, hey, IDS, add item, 594, add item. So this is just an app, okay? And this app is running inside a container inside our machine. So this is our machine. Okay, we just got this machine because we were just playing with Docker. This machine, we ran a command which is literally docker run, getting started. Okay, and we created this image by using the Docker file. We ran this, and since we port mapped from 3000 to 3000, if we ask the 3000 port for this machine, we got the app. Okay, this has a huge crazy IP, address, only because that's how they are letting other people access to this port. Okay. Any questions here? So what I'll do is I'll pause here, click on the links. If they're not working, let me know. We'll resume at 7:52. And again, we'll disambiguate if there's any confusions that came up, or if something is being clarified more. Okay, so let's resume at 7:52. Okay, so let's resume. And I would like to see if there are any questions at this point.
How would you package, say, for example, an operating system component, which might be a requirement for your program to run, for example, right? It must be in one of those taglines that you would add to this particular file, I'm imagining.
1 second, let me just share my screen.
Oh, okay.
Yeah, so your question is, how do we add some OS specific component? Yeah, so let's look at the tutorial script anyway. So what we did is just this, right? So we said, hey, whatever local files we have, do that directly. So let's say you wanted to create a, so you're talking about Windows, let's say, is that?
Yeah, for example, let's say Windows, right?
So if there is an image related to Windows, then that will have the OS component, right? If not, then you'll have to so this part is saying, hey, start with some base image. Okay, I don't know if hub.docker has Windows. Hub.docker, for example,
Okay.
let's literally look at this, because this is how you would yeah,
okay.
There is actually Windows images. See, all these guys are there, and some of them are not probably going to be free, right? I mean, some of these images may
Fair
require you
enough.
to
Yeah. Windows,
pay things,
eyes. Yeah.
but yeah,
Okay.
you'll have the components. Yeah. So what we did is like basically node was the name of the thing, and node says, hey, we actually have a lot of images depending on thousands of images based on what you want. Okay, so you can see there's like
Okay.
all these images. If you want Python, if you want Ubuntu style thing, then there's Ubuntu version here somewhere. And if you want something else, anyway, this is one of these is what we picked up.
Okay.
Yeah.
And so, for example, if we had picked up
Yeah.
a different Unix version,
Yeah.
As opposed to what we had up there on the Docker cloud, right?
Yeah. Yeah.
Will that work?
So
No,
you would
right?
want to have that Unix version. So Ubuntu, for example, is there, right? So I don't think so. There's already like so you ideally want to start with something that where you want your app to run. Even if you, let's say you're developing app
Okay.
locally, you should develop the app such that it runs in that base image plus some extra packages.
Okay.
You should not really run something. You should not do a testing on like your local Windows environment and then try to match everything on the image so that everything is there. You should actually, the whole development process can be done with Docker in the loop.
Okay. Okay, fair enough.
So everything is happening. So only text files are written on your local machine. They're always being copied onto this image, and image is being rebuilt, and then image is being rerun, and then it can actually be tested and all that. So everything involves Docker in the loop, generally speaking. So that's how people do it.
Okay. Okay. I didn't fully comprehend that, but okay.
We'll
I have a
revisit that.
general understanding.
Yeah, we will revisit that because actually, as we go through the tutorial, we'll see some of these details. Maybe we can, we'll revisit that. So I just wanted to quickly talk about some things that I left earlier. I think, okay, S3, do we need? No. Okay, let me drop S3. I wanted to just quickly show you, there's no easy way to get to the code thing. So I just uploaded that the things that I uploaded to Lambda. So that's in this folder. Okay, Lambda recommend example has those 3 files. You can zip it up and then do your own way of putting in the S3 bucket, or you can directly upload a zip if you want. Basically just text files anyway. You can actually create 3 text files in the Lambda interface and just copy paste things. Okay. And then I said, hey, we did that. So I think this was the URL, and it said, hey, if we hit the URL, okay, it's false, that's fine. But if we try to give anything extra, it's not working, right? So question UID is equal to 200 or something. It's not working. Okay. What? Well, not sure. Okay, if we do this, it's not working. So maybe, yeah, basically the payload should be a JSON payload is what I was trying to say. And just to demonstrate that, in the break, I just created a simple. So what is this other tab? It's basically the Postman tool that I was saying. We don't have to use Postman. Actually, we can just use request package in Python to demonstrate this. But I wanted a very quick way to do the same. Okay. So what I did is actually let's drop this part. Just pick this URL up, and all of you have the URL anyway. So let's say create a new request. Okay, whatever, something I don't know, description, put it in some set. Okay, this is all just unrelated to what we're doing, but okay. So anyway, we can make a GET request somewhere. So you don't need to do all this process, but they just need that for bookkeeping. So you want to send a request to this. Okay, if you want to send a GET request, and we're going to be sending a GET request anyway, we send the request, and you can see that, hey, success is false, right? But what we want to do is send some extra information. So here you can see, hey, parameters, you can send some stuff, but that's not, this key and value would have been the same as extra, as giving an extra, question mark and, slash UID, is equal to whatever, 190 or something. It will be, sorry, not like this. Yeah, this is the param key and this is a param value. That would be the typical GET request. But what is needed for this Lambda deployment is because it needs a JSON body, so JSON payload as input. So the way you do it is, for example, using Postman, you just hit body and you say is raw, and then you pick JSON as the, I mean, you don't need to do all this complicated stuff in general, but in Postman, you have to do pick body, pick JSON, and then here you give UID. Sorry, since it's a JSON, everything is string. So UID is 196. I keep saying 196. Let's say 190. Okay. And that's it. That's the thing. And you send the request, and you can see, hey, now it's actually responding. So it's just that the server or the app that we wrote here, Lambda function, it requires here. Sorry, you can see here that it requires this JSON. So it's only reading the JSON part of the request that is coming in. So you can certainly change this to make it also workable for regular GET requests that we've been seeing on the past few sessions, but that's a minor detail. Okay. So anyway, if you didn't follow that, I'm just saying that it's just that the function here is only depending on JSON, is only reading the JSON part of the input. So we have to send a JSON payload. Okay. And there are ways to do that slightly different from what we've seen before. Okay. So anyway, that was two minor things. Let's come back to Docker now. So just to summarize the two minor things, one is code that's already here for the Lambda thing, and the second thing was about sending. If you deploy this code to test it locally, testing it within the S3 environment, that's fine. You can just give the JSON payload. But if you want to externally use the URL, for example, actually you guys can use the URL anytime. This was the URL. If you want to test with Postman or something else, you need to do a little bit extra work. Okay. This anyway is there, so I won't again copy paste it. Let me close all this. Let's leave the page. Okay. Now let's come back to getting started. So what is happening here, right? So I think most of Docker complexity, for especially folks who've never seen it, is all about is captured in exactly these 5 lines, okay, which are called, typically you need to specify them in the config file. It's called Docker file. You start with a base image. Okay, so it's like a base description of what can the app see. Okay, in this case it was a node-based app, so the app can see this, and some node. Alpine is the name of a Linux version. Okay, that's, just think of it as Ubuntu. If you want, you can actually change this to Ubuntu and it'll work. Basically, you just need the node program, and then I'm just creating a directory called app within which I'm copying all my files. Okay, all my files which are related to the to-do app, and we got that app link right here, right? So this is basically it's called app.zip. You unzip it, you'll get an app folder. Okay, so that folder, whatever files there are, we're copying it, and this is exactly our files that we'll copy. And then that, because it's a, because in this case, the JavaScript file, there could be other dependencies, and we are installing those dependencies, very similar to pip, install stuff. And then we just want, when we run this in the background, since it's a server app, it has to serve something. We're saying, hey, node, execute that index.js. And once you do that, you get this. And I think all of you can access this, right? So that's what's happening. And that's the semantics. And we'll see actually now how we do it with a Flask app. Okay, let's actually do that. I think I may be deviating from the tutorial. So let me just check for anything else to be added in the tutorial. Yeah. Yeah, there are a few more things that I want to say with just this currently running container, and then we'll move over to Python-based app, like Flask app deployment, and therefore a machine learning model deployment. Okay, so what are the things that I want to say are this. Okay, so we'll revisit the Docker file again. It'll become a little bit more clearer next time when I describe the Docker file when we look at a Python app. What are the components in that Docker file, and how an image and therefore a container gets started. Okay, so for now, let's look at how to stop the container, because that was the important thing. I think should complete the minimum working example. So Docker, as I said, Docker PS, we are already running 2 things. Okay, first thing was a container, sorry, an image called docker/getting started. It actually came from the Docker Hub. I think you can look at here. This is like a GitHub repo. So if I search for Docker, Docker itself has a ton of oh wow, that's probably not a good idea. Docker/getting, yeah, Docker/getting started. So yeah, this is like a repository, right? It's something that's there, and we can pull it. Like it exactly says, hey, if you want to run this, download this and run it. This is a single line command that you should execute. Okay. But how do we stop it? How do we stop? Maybe not the getting started one, but maybe the to-do app that we started. We can stop it by running the following. Okay, Docker stop. Okay. Okay. Sorry, that the name was not correct. Docker stop. And what you can do is give either the name of the container or this container ID. Okay. So let's actually copy the container ID. Oops, that did not work. I don't know. Copy paste doesn't work. Maybe. Nope. So let's see. Oh, it works. Let's see. Yeah. So if I do Docker stop, it stopped that container. Okay. So it stopped that getting started based container. Okay. That was the base image, but the container itself is an ephemeral thing. Okay. It's not a permanent thing. So you can always start, stop, because you have the image. Okay. You always restart things. Okay. And this comes to the point of, hey, how do I save data and all that? And we'll talk about that in a second. So now again, if I run PS, we see that, hey, that thing is not running. The only thing running is that tutorial. So you can actually do extra things. So if you do Docker PS -a, you'll actually see that something, that the container that we stopped has exited. You can see the status has changed to exited. If you want to completely delete it, okay, maybe it's consuming some resources. It's actually not going to consume much resources, but if you want to delete it, you can do Docker. Sorry, let me just go up arrow so that I can get to the same ID, container ID. And then I can do Docker RM to remove the thing. And then if I do PS -a or just PS, you'll see that there's only one container running. Okay, so that's so Docker PS gives you the list of containers running or not running with -a command. It also shows you not running ones. And Docker images will show you what all images you currently have. Like, getting started is what we created, and so we have it. And Node and something else, we just got it from Docker Hub. Okay. So this is about starting a thing and closing it. Now let's do that with yeah, let's do that with our Flask. So we'll create a Docker file which will use our Flask py file and create a container which runs our Flask app. Okay, and so let's pick some app. So as you know, we have like, for example, here, if you look at click code examples, we have so many Flask apps, like Flask food service, which is what I think we saw in one of the previous sessions, ImageNet service, recommendation service, simple regression service, weather service. I think weather service is working now. So maybe let's try weather service first. Okay, so you can see this is literally, the Flask app. So sorry, Flask, Flask app. So what we can do, since we have the playground, what we'll do is let's just git clone this into that thing. Okay, so now we are in some previous thing. So let's exit that, exit that. So we are now, the previous app things were the one from Docker tutorial. So let's create our weather app. Okay, so make directory weather and cd into weather. And then, I can just get, okay, maybe I don't want to, okay, let me step out and git clone our code. Okay, so we got the code, all the code scripts. We don't need all of them, but now let's go into weather and copy from that MLOps thing, Flask weather to this place. Okay, so what did I do? I just did a git clone, and basically I just wanted to get this py file. There are many ways to get here, right? I can just do vim some name.py and then actually just copy paste that our code, right? I could have done that. Now we have this. Do we have Python locally? We do actually have it. Okay, we don't need it though. So okay, we have this py file, right? So now what we need is a Docker file. That's the only thing that we need to package this script with a base image, starting image like an Ubuntu image or something with Python in it, hopefully. Okay, or something which within which we can, even if it doesn't have Python, we can do pip, and we can do, like, for example, in Ubuntu we can do apt get install Python or things like that, right? So we did this with the initial. Remember in the first session, if the machine we said we didn't have Python, we installed Conda Python, right? So using mini Conda and all that. So we can do all that stuff. So, but let's yeah. So let's look at this. Let me create it here. So this is going to be my Docker file. Sorry, the Docker file from which I'm going to create a image. Okay, so maintainer, of course, it's me. I'll start with something. Okay, it doesn't have to be Debian. It can be Ubuntu. Okay, it doesn't really matter for us. And then I'm saying, hey, this time I'm not installing Conda, basically. So what I'm doing is, hey, generally Debian or Ubuntu, they're all basically some variants of Linux, which are very similar to each other. In this case, Debian and Ubuntu. I'll just say, hey, update, and I'll just install Python 3 pip, and then pip 3 install flask GeoPy and request. Okay, these were the 3 imports that I was doing in my py file. And then I'll say copy. It's not really weather, so actually I can just do dot, and then Python 3. What is the actual name of that file? It's called, sorry, flask underscore weather underscore service, right? Okay, let's delete that. Flask underscore weather underscore service. Okay, this is my pretty much my Docker file. Okay. What I'll do is I've just copied this. So what I'll do is I'll go back here, vim docker file, and then go into the insert mode. That can be done by pressing I. Done. Now you can paste things. So you can just do right click. Oh, you can't do right click. How to paste? Let me copy it properly.
You already had a Docker file in there, right? What happened to that?
That was for the other folder. So, okay, that's a great question. So, okay, let me write this WQ. So this is in this folder. Okay, so this has only 2 files. My Python file, which is the script that I want to make an image out of. Let's say isolated containment and isolated environment. And so every time you want to have a new image and therefore a new container, you create a Docker file to define that. Okay, so I created a new Docker file which is talking about Python installation, because the base image doesn't have this Flask and all that stuff. So we'll talk about this Docker file. So the other Docker file I can do ls dot dot. I think it's in the app folder. Okay, sorry, app folder. If you look at it, that folder initially when I unzipped it, it had only these 4 files. I added an extra Docker file there, which says, hey, copy the JavaScript files, from here, from local directory to that image that I'm going to create, and install JavaScript related dependencies. And when the container runs, run a node space, like source / index.js or something like that, right? That's that Docker file. This Docker file that I created here is very similar idea. So let's actually look at the Docker file, right? So yeah. So Docker was saying start from some OS, some Linux OS. It doesn't have to Debian, Buster, and all that. Okay, so it can be anything. It can be Ubuntu, something else, or it just needs to have a beginning. It just needs to have initial Python. Okay, maintainer. This is just optional. You don't need to actually even have this line. Actually, let me delete it. And then run. Okay, so run is just saying, hey, run some commands, because let's get Python first. So not Python. Python is already there, in this base image. So let's install pip, okay, and Python 3 dev for some reason. So let's not worry about why we are installing this. If you don't want to do this, there is an alternate way to install Conda, and we'll see that maybe in 5 minutes, which is exactly the same as what we did before. So this by the way, this line number 2 to line number 6 is just actually a single command is just saying, hey, update the packages and just install Python related dependencies that I have. Okay. So that's all. There's nothing much going on here. And then this line 7 is just saying, hey, copy my local files to this image that I'm creating. And image, just think of it as a file system. Okay, it's a static thing from which you can create a container, this isolated environment. Okay. Although I'm saying copy dot dot, copy dot space dot is just, there's only one Flask file, right? Only one Python file. You just copy that into this image. And then when the thing runs, when I run the container from the starting image, the first command that should be run is Python 3 space Flask weather service .py. Okay, that's it. So I hope this Docker file is a little bit clear. This is a different Docker file. We can go back to the previous Docker file to see what the differences are if you want. Oh, we are running out of time quite a bit. So let's run this actually. So as I said, ultimately I just have a Flask file, which is exactly what we had in sessions 1, 2, and so on. And then I have an extra Docker file. Okay. Now I can do Docker build minus tag. I'll give some tag, let's say weather app. Okay. I don't know. You can give some app. Give some name, and then dot means find the Docker file in the current directory. Okay. So let's press enter. So it's saying, hey, let's get the Debian thing. Let's install Python. Wow, it's doing a lot of things. Yeah, it's basically trying to get, whatever we said, like get Python 3 dev and all that stuff. Okay. There's better way to do this. By the way, I didn't specify version numbers and all that. And I know that, that's always a pain, right? So, but for our minimum working example, this works. So it's doing a lot of installation to eventually install just this final thing. You can see here Flask, right? Oh, somewhere over there. Okay, it installed Flask and then copied something, and then entry point is this. Okay, now that's great. Now let's see if it actually copied, because I just did it in real time. So, okay, now Docker images. Okay, so let's see what images we have. We have the weather app image. We just created it. Okay, 16 seconds ago. Okay, now since we have the image, we just have to run it. So Docker run. Again, we want to run it in a daemon mode, basically like in the background. We don't want to actively otherwise it'll not let us use the command prompt here. Run -d and port. We want to have, I think by default, I think the weather app had like 5,000 port. So let's just say 5,000 of the isolated container should map to the 5,000 of this machine. If it maps to this machine, then I can access it from external environment. Okay. And then what is the name of the app? Weather app. That's it. Okay. And you can see if it runs successfully, it'll give you a long string. Actually, this long string is supposed to be its container ID. Okay. So you will see that, for example, if I do Docker PS, you will see that the first 8 or first 10 or 12 characters are exactly the same as the container ID here. But it's actually the full container ID is this long thing. And it says, hey, what is this? It has run it. Command is Python 3 Flask weather app. And it's created some time ago, and it's running. Okay, so it's running, and therefore you can see extra 5,000 came up, and this is just a gimmick from the playground to, and then if you click on it, again, the way we've written the way we've written our app. So actually, let's go back to GitHub, and what did we copy? A weather service. You can see the way we've written our app. It says, hey, whenever you hit that URL, this function starts. This function is saying, hey, let's set data success to false. And if you have not given any message, okay, return data, right? If there is no message, if there's a message, do something. If there's no message, it's by default returning something. And that's the data object, and that says success is equal to false. And that's exactly what we got, right? So where is this? This one. Yeah. Okay, let's actually, we close the to app. So anyway, it doesn't work. So, okay, so this is good. Now let's do the get request. What is the request? I think MSG message is equal to Chicago. Oh, that did not work. Docker.com /?. Okay, you can see this is literally what our app is actually responding to. Responding. So you guys can try it. I mean, this app is open anyway, open. And this whole thing is a playground, so don't insert your passwords or things like that in here as much as possible. In here, as in like in here. Okay. So that was the app that was supposed to work, whatever, 4 weeks ago, but at that time the National Weather Service's API was down, I think. So now it's working. Okay. So is there any question at this point? So I want to, if you understand this and deploying this type of Flask app, then the Flask app, which involves the model prediction, is pretty much the same, right? It's just the prediction function just changes. Instead of us, inside here, inside the function, instead of like, hey, look up weather and just return it back, we're going to do something else, which is look up, hey, give me the prediction and return it back. Okay. So any questions at this point?
Any chance you could show that Docker file one more time?
Yes. In fact, the Docker file is exactly the same as what we have in our notes, right? So let's go back here. Sorry, what I did was deviate from the note this section a little bit. Go to, let's say, oh yeah, in the end. Let's go all the way to the end of the section. So you can see the Docker file is right here. This is the Docker file. Okay, I mean, this was like doing it on a local machine, or even not, if not local machine, like the AWS instance that you have. If it's, it has limited memory, but modulo that, it has limited resources, but modulo that, they should exactly, if you just follow this, it's not weather.py. Sorry, this link is not correct. I mean, you just get it from here. Okay, that py file you can get, not just weather. Okay, you can, let's say, do food service instead, just to get your thing going. Yeah.
Okay.
Yeah. So the file will be exactly the same. Only thing is you just need to change the whichever Flask, whatever the Flask file's name. Yeah. And also here I'm explicitly saying copy weather.py to weather.py. Instead of that, you can say, hey, copy the whole directory dot to dot. Okay. And this is the extra thing. So we are taking a base image and we are adding something extra, and then saying this is our full image. Okay. You started the base image, you basically use Dockerfile to define a new image. Okay. The new image will have your Flask file. And once you have the new image with the Flask file, if you just run it, it'll run the Flask app, because it's literally saying run the Flask app every time the container starts.
Okay. So in the same machine, right, I can have 3 different environments, so to speak. So in the traditional sense, there would have been a development environment, a testing environment, and some other testing environment.
Yeah.
In the same way, I can have a development container.
Yes.
All my files and corresponding Python version and everything, all that into that, right? In a different folder, I can create a correspondingly different environment. And once I'm done the development, I can just simply quote unquote Docker it up and kind of create the other.
Okay, so this thing of dev versus production is a little bit orthogonal to the Docker workflow. Docker workflow. So I think what you should do is look at the getting started information. So for example, this app that they off, this JavaScript app actually says, hey, if it's dev environment, then do something. What are the dependencies? If it's a production environment, there will be some different dependencies. You can actually see that.
Oh, okay. All right.
Although it's JavaScript, I don't know if you are familiar with JavaScript, but
I am. Yeah.
This will show you a sense of, hey, don't copy all the node underscore modules, like in a prod environment, right? So
yeah, but that's a more advanced and a little more complicated way to think about what to install versus what not to install. And you're telling Docker system.
Docker is orthogonal in the sense it's portable, right? So you do your dev as if it's this environment is kind of removed. The issues with the environment are removed, right? Because whether it's production or development, the only thing that's running is the container. As long as you can specify in the container all the dependencies of your script, then it should be exactly the same.
Yeah, it will get you the particular file that you're looking for, the particular packages that you're looking for. As long as you can specify all that in this script file, it will get you all that in a container, and then technically your app is guaranteed to work as long as it is ready for that particular thing.
In fact, we ran out of time today. I was going to show that, hey, we created this weather app. The next few steps were to just say, hey, let's dump it to AWS
Right.
And
That's what I
exactly the
was
same thing.
thinking I would do. Yeah. Okay.
Yeah, that's exactly the same thing. We'll see. We only have 6 minutes, but basically we don't want to dump it onto the AWS container registry, and then we can run it on AWS. The exact same thing. So
Okay.
there's no change. Yeah.
Okay.
I mean,
Fair
the change
enough.
will be just setting up the container registry, putting it into container registry and just calling it from container registry. Right.
Okay.
That's all. That's all outside the app. The app itself is at this point it's sealed. Okay.
Okay.
Of course, you
And
can say,
this.
hey, how does it talk to new data and all that? There's some nuances there. Maybe next week we can pick that up. Yeah.
Okay, certainly. And when you okay, we will pick up how the dumping works. It's a file essentially. That's what you're saying.
Yeah. So this is basically some sort of this is basically a local file currently. Local in the
Okay.
sense local to this machine. We want to push it to it's like it's very similar to GitHub, right? If you have a local
Okay.
whatever code file, you want to push it to GitHub, you just say git git push or
Push.
something,
Okay.
right? So here very similar, docker push is essentially the command.
Okay.
But
Okay. Okay.
there's some extra things need to be done because AWS, by default you need to have authorization, right? So you need to somehow, very similar to the PEM file that you were dealing with earlier,
Okay. Okay.
you need to have some authorization to be able to push this to your AWS account. Yeah.
Okay.
Yeah.
No, I understood. Thank you.
Yeah, but I think since we're running out of time, I don't want to rush through that thing. We'll pick it up. I think
Yeah, that's
early
good.
next
This
week.
is my project, so that is. Don't rush through this. No, I'm joking. Thank
A
you.
lot of folks generally do introduce Docker in their projects. So it's not that I'm not saying that everybody should do that, but at least the last time we saw that a lot of folks did use Docker as a part of like testing out Docker when they were deploying their projects. I mean, if they were deploying machine learning models. Yeah. Um, so let me actually see what I can cover in the next few minutes. Yeah, let me, since we only have 4 minutes, we can look at something. So by the way, this is just the same Docker section. So let's go back to the table of contents here. What we've done in this chapter, okay, take some time. Okay, we saw introduction to containers, and today we saw Docker. Okay, you just need to know the moving parts. There's a main important thing is Docker file, and if as long as you can insert your script, and as long as you can say, hey, install the dependencies somehow, like pip install or somehow, and that's it. And once you create an image, running the image is as simple as Docker run image. Okay, so running the image as a container is as simple as what we saw earlier. What we wanted to do next, and we kind of ran out of time, is to say, let's put this image, whatever we built, into AWS in some location. It's called a registry, like like GitHub or Docker Hub, and then use that image within a managed service, and the managed service is called Elastic Container Service. So instead of Elastic Container Service, we could have used Kubernetes. Okay, Kubernetes is a it's again another what is called a container orchestration technology. Even Elastic Container Service is a container orchestration technology. By orchestration, we just mean handling the containers, handling images, handling containers. Okay, and what they do is ensure that there are resources. If a container immediately somehow terminates because the underlying machine fails, then they'll spin up another machine and put the container again there and things like that. Okay, but anyway, we'll see some of the details early next class on containers, registering container service. So just deploy our container on AWS. Okay, I mean, at this point we can actually deploy the container on AWS directly, right? So what we did here, right? Just think of this as your AWS machine, right? Let's say you install Docker on AWS machine, and that can be done as simply as sudo. I mean, if you did the AWS machine that we generally use, like Ubuntu, sudo apt install Docker would just install Docker there. Once you have that, it will be exactly this terminal, and so you can do exactly the same things what we're doing here. In fact, you don't even need the terminal. If you have the Jupyter session, in that you can open the terminal and do all this stuff what we just saw, right? Did I have to say something else? Okay, I think since we are running out of time, if there are more questions, please stay back and ask. I know there are a lot of commands that I'm typing. Sometimes I may be glossing over something that I assume you know, but you may not know. So do ask on the chat or through email, or maybe stay back and ask me. Okay. So yeah, that's it. Thank you for your attention, and I'll stop recording.